Hi everyone, welcome back. In the last video we learned how to generate Aruco markers, and in this video we are gonna focus on to the detection of the Aruco markers, and we are gonna use from here, which is gonna be draw detected markers. So this is gonna be helpful at the end to be able to draw the markers in our image, output image. But for detection we need to go to another class inside this module, which is gonna be Aruco detector class. And here for this video we are gonna learn how to initialize the constructor of this Aruco detector. Also we are gonna little talk about the detector parameters, because these are really comprehensive, refined parameters also. So maybe for these parameters we can make another video. That's my plan. So we are gonna learn how to initialize simply, and also we are gonna focus to the detectMarkers function. So basically we are gonna detect and we are gonna draw our markers. Also I want to show you, because also in the previous video I little mentioned about the usage of this Aruco markers. This was another video before, so early time I did in my home. So I just simply detecting the Aruco markers in the ground, and I'm just putting any video, any image, anything you can put around here. So this is one of the example to the augmented reality, simple example to the augmented reality area with the Aruco markers. Also, as I said, these are really useful for the robotic area, because these are really accurate. We are gonna see in the code part also how it's detecting. I already prepared two images. One is the 3D image. These are simple images, but it doesn't matter if your lightning is fine in your environment. It's gonna be detected easily by the OPENCV Aruco marker class. In the this example also we see. Anyway, for this how to say, for parameters we can discuss in the code part how they are looks like. This was the code from the previous video, and here we just simply need to initialize the constructor. As I said, maybe dictionary can stay for now, because we need to use for the constructor Aruco and just Aruco detector class. And all I need to do is just initializing this Aruco, or just simply calling detector. Okay. So but as I said, this class needs some parameters, which is gonna be the dictionary we already prepared. Let's say dictionary, and also need detector parameters and refined parameters. As I said, these are really comprehensive, these detector parameters and the refined parameters. I just want to put us for this video detector parameters to be able to show something. Maybe in another video we are going to discuss the parameters, because these are, as I said, really comprehensive things inside. I'm going to show also, and just detector parameters and equal to CV Aruco, just calling maybe the default constructor. Okay, and that's done. So we need to give this also. I don't want to touch refine for now. This is, I want to show something, because that's why I'm putting for now. Our detector is done, and the next thing we need to do is just calling the detectMarkers. Aruco detectMarkers function. The first thing we need to do is just giving image, which is gonna be, I'm not yet defined that. Okay, image is equal to CV imread. Okay, let's start with this one, simplest one, and I put that. I want to get it, and after that what it needs, the dictionary. I need to use the dictionary which is available for my image. For example, here we can see 1 2 3 4 5 6 by 6 Arucos, these examples. So I need to define my dictionary accordingly. 6 by 6, 6 times 6, like this, I think. Yeah, okay. And the next is just put dictionary, and other one is I need to define after the dictionary the corners, IDs, and parameters maybe, or rejected points continuous, like that. So first of all we need to put these IDs, which is gonna be vector, and this can be integer. You can put also CV mat, I think so, but yeah, it's better to use vector in these cases. So just marker IDs, and after that we need to also define marker corners and the rejected corners, which is gonna be also vector of vector for the CV point float type, and these are gonna be my marker corners. For I'm gonna use this for drawing the drawing function, so it's gonna draw at the end. It's gonna be useful. And rejected corners. Also, we are gonna talk about this rejected corners. So what's required? First of all, this image and dictionary, but also maybe we can simply use another one, image, but okay, this dictionary, or we can simply just calling the marker corners, and after that let's see detect markers this is, and also I need to give dictionary, I think so, yeah, here marker corners and marker IDs and rejected corners, and this function should be done by this. What it says, maybe simply like this. Oh, something wrong around here. What is we are missing? Okay, detect markers, but of course we are wrong because we need to call the detector detect markers, so we just simply doing like this. Yeah, that's why I'm suspicious why this is asking the dictionary. Let's check again. So yeah, that's why we are making mistake. Okay, anyway, now we are on the right way. We already detect our markers, we get our output. Now we can directly call the CV Aruco. Now we don't need detector. Draw detected markers. You can draw to the same image, and you can draw the marker corners, which is gonna be here, and the IDs is gonna be the marker IDs, because I want to see in the output what is the color. Maybe it's okay, default is blue, I think. Now just show me that image at the end. Let's see how it looks like. Okay, so yeah, it's detected, but you see these are missing. Why these are missing? Because of they are in the edge case, and the default detector parameters are not able to detect these Arucos. That's the one I'm talking about. What I mean is, if you go to the detected parameters, you see many parameters in here. I already highlighted one of them, which is gonna helpful for us, which is kind of but this is not the one. What was the trash? There is something win size max. This is related to the this is gonna be related to the edge case, default 23, but increasing this is gonna help us to detect the edge Aruco markers. For example, if I just take this and calling that, what was the name, let's go again. Okay, this one, adaptive trash window size maximum. So also, if you go to the explanation in here, what is in that one? Okay, here I think increments from adaptive this or this one, maximum window size for adaptive thresholding before finding contours. So this is simply just increasing the width. So in the edge cases also gonna be increased, so it's gonna be able to detect the edge cases. At least one of these parameters at least little gonna help that. So we can just calling this max, which is default 23. Maybe we can make it, let's say, really increase 555, let's say. And now as you can see here, it's under this side, is able to detect one of the edge cases. And if we increase little more, maybe 1000, and now let's see. Okay, now it's also able to detect this, but these are still not detected. Maybe we need to play with the other parameters, because yeah, but as you can see, you just need to play with these parameters, which is very detailed. And yeah, I just wanted to show you, if you are not able to detect a very clear Aruco, it means the detector parameters are going something wrong. Okay, We can remove this for now. Just I wanted to explain this, that that's not such simple for the Arucos. Okay, they are really accurate, but you need to define your parameters accurately also. That's very important. And I want to also talk about this rejected corners, because we already get this marker IDs and corners. Corners are just giving you simply the detected rectangle around this, and this kind of, and the ID is just written in here, the number. But what about the rejected corners? For that, I want to show you what are my rejected corners, why they are rejected. Then just simply I want to make a for loop for getting each vector of the rejected one. Just point 2f, just say vector for each rejected corners in here, and for each point I want to draw a line. So I want to draw the rejected regions, so I want to see, and I want to talk about them a little bit. So here simply just I is equal to 0 smaller than the y dot size. Okay, and after that simply just calling line function. Okay, image is gonna be image, and point 1 simply is gonna be the y dot I, and yes, and the second point is gonna be just I plus 1, but should be okay like this, and modular of the 4. Oh yeah, 4, because 4 corners for each member, each element of this vector, because rectangle has 4 corners. And the next is gonna be the color, which we can define our favorite color, which is yellow, and the thickness 2 is okay. And just let's see how it looks like. Just make here maybe integer. Okay, so these are my rejected regions. You see why this is important? Because maybe for some debugging reasons, the user, the developer, need to see why where are my rejected regions, so at least he can see, or he can update maybe some of these rejected regions are also Aruco, maybe. So he want to know somehow, so that's important also. But you see there are many rejected regions. In some cases maybe you also need to deal with these rejected regions, so that's important. My focus for this video, detect markers, draw detected markers. This is just optimized drawing Aruco markers, so you can also draw some kind of for, but it's optimized and easy to use. It's just showing you the output visualizing for the visualizing result. And also we little talk about this detector class, very important, this detector parameters, also the refined parameters, which is the other one. So yeah, as I said, these are really comprehensive. Maybe we are gonna make a different video for those. Also we talk about the main function, which is detect markers, so this is important. I'm done for this video. Thanks for watching. See you in the next videos.